So this is a brown bag about dogfooding fuzzing concepts with GitLab-Runner and GitLab-ci.yml. And I'm actually really glad Jenny was able to make it, because this uses, the intention with this is to use the MVC fuzzing that he is working on right now on our own products. And that's the dogfooding part of this. All right, and share my screen here. Oh, I thought I knew where it was. This happens to me every single time you present. All right. So my name is James Johnson. I am on the vulnerability research team. And today we will be talking about fuzzing theory and how I went about dogfooding some of the MVC work that's going on with coverage-based fuzzing with GitLab-Runner, and additionally, how I set up fuzzing for GitLab-ci.yml parsing. So the theory aspect will be very high level, not going into super detail, but generally, whenever someone sets up a fuzzing campaign, is what some people call it. If you want to fuzz something, you have to identify first the attack surface or the entry point, and then how you're going to generate data. And then you send it to the target program and you monitor for unexpected behavior. Now this is a very general approach, and it is not necessarily security related. You often find security related bugs, but you can also shake out a lot of normal bugs, and you can specifically search for just general unexpected behavior instead of specifically crashes or security problems. So in a simple case, you will have a target that accepts binary data and processes the data. That is the simplest to work with as far as fuzzing goes. And test cases or target programs may look something as simple as this. They could be a library that parses data, say like ffmpeg or an image parsing library, or something that works with fonts. It's very straightforward. You send it data and it does something with it. This is very straightforward to work with fuzzers, because the data you send to it is one of the easiest types of data to generate from a fuzzer. You just generate random data and send it on its way. However, that is not always the case. What if a target talks to a remote server via REST API, or it's got some custom authentication going on and there's no raw blobs of parsing that are happening within the target? Targets can be very complicated, and it makes it hard to really know where to start if you want to fuzz that target. So to me, this is the main solution. It's how I always view it. You need to break it up individually and perform targeted fuzzing. You pick a single aspect of the complex target and you fuzz that intensely. So for each of these different examples that I had on the previous slide, say you could fuzz specifically how it talks to the remote server, or how it parses JSON requests, or maybe you look at the state machine of the target as it's operating on things. So that way you'd have to set up your fuzzer differently. It's not so much data that you are fuzzing, but more sequences of actions and the values within the data. So if you are fuzzing the JSON data, you may want to have actual well-structured JSON values instead of just raw data itself. But there's a problem here. It is, this sounds very simple, but you can kind of go down rabbit holes you weren't expecting, and it's something to be aware of as you go about fuzzing. So what if you choose to fuzz the remote server network communications? You may just be fuzzing that languages, whatever library they're using for HTTP parsing, you may just be fuzzing that instead of your code itself. And the same goes for JSON and YAML parsing. If you aren't aware of exactly how your fuzzer is working, you may just be fuzzing the libraries that your code uses instead of the logic within your code. So targeted fuzzing is always much more effective than a one-size-fits-all solution. although that 100% definitely has its place for a lot of cases, especially when it's just accepting raw data and you can send it on its way. If it gets a bit more involved than that, you need to know about what you're fuzzing. You need to know what it's expecting so that it doesn't, the actions you're trying to perform on the target aren't thrown out immediately. Before I move on, does anyone have questions? No? All right.
Good.
Oh, cool. So I'll move on. Let's move on to Dogfooding GitLab-Runner. So let's think about it. Is GitLab-Runner a simple case? And what functionality does it have? At first, when I was thinking of fuzzing GitLab-Runner, and it wasn't just me thinking about it. It's something that we had talked about working with Yevgeny and trying to identify targets within or projects within GitLab's codebase that would be ideal for dogfooding the fuzzing features being developed. But GitLab-Runner is not that simple. In some aspects it is, but it does talk to a remote server, uses authentication, talks via REST API. It does a lot of different things. I would say it's definitely not the simple case. To me, some of the more interesting things that it does are dealing with the artifacts. It's got some interesting logic in how it processes artifact zips from other jobs within the stage, or I guess just other jobs, and as well as the way it handles the cache. It does do some YAML parsing. I don't think that's really so much the default case, and then a lot of GitLab setups, by the time the YAML or the JSON data gets to GitLab-Runner, it's already been validated and should be very well formed because it's gone through GitLab even to get to the state where GitLab-Runner uses it. And then it runs code in various types of executors, Docker, direct shell, it spins things up in Kubernetes. So it is a little overwhelming thinking about, okay, how am I going to fuzz this and which aspect am I going to fuzz? Like if we wanted to fuzz how it spins up Docker containers, for one thing, that would not be very fast at all. It would be extremely slow. During fuzzing, speed is important. If you can only do one iteration per second, and your fuzzing job runs for an hour, you'll only be able to do 3,600 test cases in an hour. So you do want to sort of have in mind what the performance aspect of it and what the impact is on fuzzing. So this, there are definite pros and cons about this, but it was the simple case, and for testing out the features being developed for fuzzing, it's the one I decided to go with for now, just to get something working and dog food the changes being made. So one of the pros is it is directly testable. It is a distinct feature within GitLab-Runner. And one of the major cons, though, is that you might be fuzzing the Golang YAML parser itself. And we already talked about that, and I will definitely circle back to that again at the end of this presentation. All right, so moving on to dogfooding. Since we are dogfooding, this effort was largely based on trying to use the existing GitLab features or the features being developed right now. And this is a link to a demo project that Yevgeny put together. And it uses the sample, is this not open? There we go. It uses the features that are currently in merge requests waiting to be merged. Oh, let's go back here. All right. And the coverage guiding fuzzing features being developed support GoFuzzing with GoFuzz. GoFuzz compiles the Go binary in a way that it'll work with libfuzzer. So you can compile it to a static library and then link it with libfuzzer using Clang. And so you don't define a main function. What you define is a fuzz function. And then that is what goes into the static library. When you do the linking with Clang, libfuzzer itself defines the main function. that then calls your fuzz function that is in your test harness. And here is the Go code that I use to directly test the YAML parsing inside of GitLab-Runner. And the fuzz function here is at the bottom, and it just calls this parse YAML function. And yeah, I took most of this code directly from unit tests. I think unit tests are a fantastic way to see how code components within a project are directly run and tested. And it's a very good way to build on top of, or it's a good approach to create the fuzzing harnesses by building on top of unit tests. All right, and so this YAML here is the YAML that was, this is the way it's planned. And Yevgeny, if something's wrong about this and it's maybe changed a little bit, let me know. But I'm pretty sure this is about what's planned. It was what was in the demo project. I did have to change it slightly. So the script section, I needed to make it use a specific Go version. Go, I think in the image that is used here, this one, it's Go version 1.12, but for GitLab-Runner, it needs to be Go 1.13. And then the other thing that needs to be changed, GoFuzz needs to be rebuilt for Go 1.13. And there was also a problem using Go GeoFuzz when there wasn't a previous job that was run. And I may have set something up incorrectly, but this is all why we do dogfooding. Figure things out and figure out how easy it is to use the product and shake out bugs. So I've created 2 issues on those, and so I'd say that's successful dogfooding. We were able to shake out a few issues, and I'm going to show you now that we are actually running fuzzing. All right. Oh, and since we're not using GeoFuzz, I took all of these arguments directly from the GeoFuzz code base, so that it would run in almost the same way as if GeoFuzz had run it directly. All right, so this is the fuzzing job that I actually spun up, and this is on GitLab-Runner itself. And this one only ran for 5 minutes, but you can see here it is running, and it is doing 5,000 executions per second. Depending on the target you're fuzzing, that seems all right. Sometimes you can get the executions per second to be a lot higher, but from a user perspective, they're not really going to care so much about that unless this is something they do and that they are interested in and trying to optimize. All right, let's go back to here and talk about exactly what it's doing though. This is the type of data that was generated using the fuzzing harness that I made. And I did call this out that we may just be fuzzing the YAML parser itself inside of Golang because I'm not making the YAML well-formed, it is not structured. And this is what the fuzzer came up with. Now the fuzzer is a coverage or feedback-driven fuzzer. It mostly uses code coverage to determine if new code paths should be or were followed by a certain input. So if one input caused new code paths to be explored, then it would prioritize and continue to mutate that specific input in an effort to make it go down even more unique code paths or further into the tree. And admittedly, I've not let this run for a long time, and I do most of the exercise was around using the features that are being developed as part of the coverage-based fuzzing MVC, but I haven't found any bugs on it yet, and that's about what I expected actually for this scenario. Some of the other scenarios that I wanted to fuzz, but I didn't have time to put them together for this slide, I think I have it. Maybe I didn't call it out. No, I did. So parsing the YAML data was an easy one. How zipping and the cache is handled. Specifically, I would set up the fuzzer to fuzz the file names within a zip file. There's some kind of weird logic there, and I've noticed that if you add null bytes into a string and some of the built-in Go file path functions, when you're determining the relative file path and you have a null byte in one of the strings, it doesn't behave the way I thought it would. And so that would be something that I would want to fuzz as well, specifically the file names inside of a zip file. So again, targeted fuzzing, right? And the cache, that's also the same thing. You can specify a key for the cache that's used by the job. And there are specific checks that happen there, also with relative paths. And that logic, if something's wrong, might allow you to impact jobs being run on from different projects. It depends on the executor being used for in that job, though. So those are other things that I would be looking at. All right. Any questions about GitLab-Runner and how that was set up, or the results?
So the fuzzer really doesn't know that that's YAML, right? It's kind of just passing in byte strings, and a couple of the things in the corpus ended up having some semicolons in there.
Yeah, so I did seed it with some data. Let's see. I think if we go here, and this should link to the merge request. Here we go. So in this merge request, I took some of the valid test YAML from the test cases and added them into this YAML corpus seeds directory. So I seed the corpus of inputs that the fuzzer uses with actual data from the test cases, because I didn't set up the fuzzer to generate raw or valid YAML from scratch. And so I think that's why it has a kind of vaguely familiar shape to it, instead of being absolutely totally random. Yeah. Let's see.
Yeah, so, yeah, sorry.
All right. So things that I want to do to improve on it. So one of the focuses was to use the product, use the code being developed, and shake out usage bugs. But we do want to actually fuzz GitLab-Runner and make it more stable and more secure. So now that things are set up and in place, we have a fuzzing job that builds a target and runs it and generates crashes. If it finds any, uses a corpus. Then we should be adding new targets and possibly generating valid YAML data, like the zip and file names thing was very interesting to me. The network data, it's, I don't know. I'm on the fence about fuzzing the JSON REST API that GitLab-Runner uses. The attack scenario there is, I don't know if it's really there. Maybe it is. If somebody could impersonate GitLab itself, like the runner is trying to talk to, then it would be valid. It sounds like a very slim thing to me. So again, I would also go back to the GitLab-Runner code base and try and figure out, understand it a bit better. There's a lot in GitLab-Runner and it does a lot of things. It has a long history. So I'm sure there's other interesting things in there as well that could be targeted. All right, before I move on to the next part about fuzzing GitLab-ci YAML parsing, does anyone have questions about GitLab-Runner?
So not a question, but yeah, just a note. So so thanks for opening the issues. So I'll add more handy Docker files, because currently there is only one handy Docker image, and then I'll also take care of why GeoFuzz was not available. I think maybe because I changed the the name. It's not like there is the GoFuzzing example still doesn't work because it's only up to date on my computer. Because
okay.
some of them are not merged, and I think maybe it's because we changed the name to GitLab-Fuzz.
So it was able to download it. Let's see.
Yeah, but it should download like GitLab-Fuzz, I think, and not.
Okay, here we go. It downloaded GeoFuzz. Oh, okay, and so it's probably downloaded an old GeoFuzz binary and not a new one.
Yeah, maybe. Okay, I'll
so GeoFuzz did run when it talked to the API.
But it said just bad request. Yeah.
Yeah.
Yeah. Okay. I'll check it out.
Yeah. Cool. And on the flip side as well, I probably made a mistake setting it up. I've never used it before myself. Right. I've played with the examples that you have set up, but setting it up from scratch, there's probably a high chance that I set something up wrong. So take with a grain of salt. I made the issue, so I wouldn't forget about it.
Yeah, the main thing is like in this job here, if you're running the GitLab GoFuzz, you should get a report, and then that should show up on your security dashboard.
Yeah, yeah.
Or like that's the main benefit that you lost out on.
Yeah, well, and that isn't present on GitLab.com yet. That's almost merged in though, right?
Yeah, it's being reviewed.
Yeah, it's been a long process. I've been watching that go on. All right, well, cool. So I will say some of the hardest parts about setting this up was just understanding GitLab-Runner and what should actually be targeted. And I ended up settling on the YAML parser because I knew where it was. I knew how to, there was a very clear path to set it up, and I wanted to just start using the MVC features that you had developed, Yevgeny. But I did find myself kind of getting lost in just reading all of GitLab-Runner, trying to understand the different aspects of it instead of just picking one and implementing something. So this can definitely be improved upon.
Yeah, so James, that brings up this question of like, part of the hard part of fuzzing was actually the implementation on the project itself, right? Like,
yeah, like there's choosing what to fuzz even.
Yeah, there's the two issues you opened, which are things that we can help out on kind of the architecture side, but there's a certain level of work that has to be done that I guess what I'm saying is I don't know if there's any ways that we can help out on what you had to do on the GitLab-Runner side.
Well, and the unit test, I did end up just going back to the unit test and trying to see if there were good unit tests that demonstrated how different aspects were leveraged. So ideally, I was trying to find a high-level entry point to GitLab-Runner that would let me hit a lot of the features inside of GitLab-Runner, right? Mm-hmm. But there's a lot of things you would have to do for that to even happen, like if I found that entry point, right? So there's the state of GitLab-Runner itself, have to generate valid JSON that's well-formed and everything that it's expecting. So it gets increasingly complicated the higher level you want to go. But the tests found in the project were a really good starting place, at least for me, to get this up and off the ground.
Yeah, I think so I think it's a really good dogfooding for a very basic case. I'm not sure if like we can do, at least in that case, something to help out with, because I think it's more of a kind of design question. Yeah. Because like you need to understand. I mean, GitLab-Runner is a okay place to do dogfooding inside GitLab, but it's not the best. If we were in GitLab and we were just looking at projects to dogfood, I wouldn't choose GitLab-Runner as the first place to try continuous fuzzing, because it's more of a design question, and where are like the projects with with a greater attack vector, right? So like probably I would go maybe to C++ projects that are hosted on GitLab, some of them. If there is a Go project that the attack vector is very easily, I mean, you very easily understand the attack vector on the specified GitLab project, and you understand, okay, so yeah, this is the entry point. Any unauthenticated user is controlling this input, and obviously we should parse this input. In GitLab-Runner, it's much more complex, and you know, from I mean, I need to look I'm not very familiar with GitLab-Runner, but I need to take a much deeper look to understand if there is an attack vector at all. I mean,
yeah, well, and that's what I was running into. Is it's not, it is hidden behind a few layers already, right? It's not something you have very direct access to. I think even when you are in a Docker container that was spawned by GitLab-Runner, I'm not even sure if you could talk to it then. But it's let's see. At least with this, my understanding of the intention behind this dogfooding was to find a GitLab Go project to fuzz using the GoFuzz that your features that you've been working on, Yevgeny, support, right? Yeah, and so there are definitely other projects on GitLab.com in general, but that are like C++ based and would have memory corruption or things like that. I don't know if GitLab has anything like that.
A Go project is also fine. I'm not super familiar with the design of GitLab-Runner. Like the idea that we talked and in some of the conversations that we had is like if we eventually user would be able to, let's say, not execute code because it's more of maybe a logic bug, but just crash a GitLab runner and let's say perform a denial of service on the shared runner on gitlab.com.
Yeah.
So like what is the input that is being parsed by GitLab runner in that area? Because maybe just maybe just some kind of queue or an event which the user doesn't have any control on this input.
Yeah.
So I'm not sure like it's a good enough attack vector.
Yeah.
To parse. So but like parsing the YAML, just for the purpose of dogfooding, I think it's a great example, and you found some issues already that I'll take care of.
Yeah, and it's so I actually there was another reason why I liked using GitLab-Runner because it did work with similar concepts as the next part of the what I'm going to talk about, and that's fuzzing the GitLab-ci YAML parser, and that is kind of a one-off, but it covers the same topics that we have talked about already, and except from a different perspective. I'm going to share my screen again, and here we go. All right. So this was something that I had run into personally a few weeks ago with some YAML data that I was trying to use on a project, but I was getting 500 errors, and it was really odd to me that I wasn't getting validation errors. It wasn't telling me what was wrong. And so I thought, okay, there's a lot of or YAML data, and this structure of data is used all over GitLab, and again, also directly in GitLab-Runner. So maybe I could use, maybe I could shake out bugs in the YAML parsing. And so this is also very targeted fuzzing. And another aspect of targeted fuzzing is that you can choose what types of errors you're looking for. So in this case, I'm not looking for memory corruption errors. I'm not looking for, you know, maybe denial of service. I wasn't checking for long timeouts or anything, but I'm specifically looking for errors that are not validation errors, because if those are returned or are raised by calling the function to parse the YAML, then it shows up as a 500 server error when you try to use the YAML. And this is the project that holds my code for it. If you have a link to the slides, you'll be able to click it and look at it. But I will talk about the code a little more here. This is one of my side projects that I'm working on for fun. I've made a lot of grammar-based data generators, basically. They're not a full fuzzer. They don't instrument the program, but they generate the data based on a grammar. And ReSmac does that. It is Rust-based, and I've made it to be as fast as possible. And so I wrote a Ruby gem that wraps my grammar for GitLab-ci.yml and then exposes the Rust library via FFI. And then it also minimizes test cases that it finds. As you work more with fuzzers, if you have test cases that are minimized, your life is so much easier because you don't have to spend forever trying to figure out what exactly in the test case caused the problem. Sometimes it's very obvious, but a lot of times it's not. And for this topic of conversation about fuzzing GitLab-ci YAML parser found in GitLab, I'm not going to go into too much detail aside from talking about the code and just talking about it as we go through it. So this is how you can, this is how I call the YAML parser function found within GitLab. It's Ruby code, and you have to run it using Rails. What is it? I'm blanking on the name. There's a Rails function that you can use to call a standalone script in the context of the Rails application. If you don't use it that way, then you have to have, I got up to 20 separate requires just to try and get all of the includes correct. And it was a major pain. But yeah, you have to run this in the context of a running GitLab instance, or at least the minimum set of what's required for testing, which I think includes a database. For those reasons, I haven't set it up in a job or a pipeline yet. It's just local. And now this is the main function that calls the fuzz once function that I had on the previous slide. So fuzz once is very simple. It just calls parse this YAML. And if it raises a validation error, I don't care about it. But if it raises any other type of error, I want to know about it. So here, this is what most fuzzing main loops generally look like. There's a loop, and you call a function to do one iteration of fuzzing, and then you handle any errors that you see. Additional features you might see in fuzzing code might be something like code coverage, managing a corpus, that type of thing. Generally, though, they are pretty simple. So this one does 1 billion iterations. Usually I just Control-C it when I'm done. As I was developing this, since this is not in a job or pipeline, that doesn't really matter so much. But here, this is the Ruby gem that uses the Rust library via FFI, or exposes it via FFI. And in that Rust library is where the grammar is defined. So the YAML is made up of stages are required, optional includes, optional workflow, 0 or more jobs, and then an optional variables. And I didn't get to implementing image and services. And then each of these are also defined. So include is defined right here. It is 1 or more include items, right? And an include item is made up of these objects. And this is the type of YAML that it generates. It is roughly valid. there's additional logic that happens when parsing is performed to make sure, like, if you're referencing a job, or let's say you have a trigger that's supposed to trigger a pipeline on a different job, the parsing will validate that that section is valid. So this doesn't handle things like that, just the structure of the YAML data should be correct. And this is actually YAML data that causes a 500 server error on GitLab.com right now. And I have a minimizer that minimizes this down to this on the right. And minimizers are super fun to implement. It does a binary search through the data and removes chunks at a time. If you remove the chunk and it still crashes the same way, then you didn't need it. And then you continue on binary searching through the data, removing things or keeping them as you continue. So it does 2 passes. It splits on new lines and reduces the data that way. And then once it's reduced it by splitting on new lines, then it iterates through every byte, or binary searches through every byte in the file to reduce it even more. But yeah, and the job specifically is, or the error specifically happens if you have a needs field and a dependency field in the same job. Yeah, then you get the exception that I keep running into. Any questions on that before I move on? No?
Yeah, maybe about the minimization. I'm wondering, you said you're searching through every byte.
Yeah.
Is there like a stop condition, or is this some sort of exhaustive search where you try to basically check all the bytes and then?
It is exhaustive. So whatever is the and so it is generic. It operates on a list of items. And here, I'll just pull up the code. It is, let's go up to here. Here we go. Reduce lines. It's not just lines. It's just an array of items. It's kind of misnamed. But you call the reduce function and you tell it what to split on, and it splits it into individual items. So that's like at the atomic level, right? Those won't be split up anymore. And then this collection of items, it binary searches through the collection of items, removing blocks of items and testing to see if it still crashes. And that's what happens here. So it's split into a before, and then the chunk being tested, and an after. If the before and after concatenated together, it's like right here. Actually, is this big enough? Make it a little bigger. All right, so if this is valid, just the before and after, then that means you didn't need the chunk of data that you're checking, right? And then you just return blank, meaning the data I'm checking, we don't need it, right? But if you do need it, then you have to split the before, or not the before, the chunk you're checking into its own before and after, and then check each of them. So it's recursive, and binary search isn't like, it uses binary search concepts, but it's not quite the same as trying to find something within data. You're trying to remove things, but you do have to check to confirm that you need an item inside of the collection when you split it. So you split it, you have a collection of items. To confirm that you absolutely need one of them, you have to reduce it down to just a single item and remove it and see if you need it or not. So it is exhaustive, and that's why I perform it in 2 stages, where I think it's right here. Yeah. So I split on new lines, and you pass it a block that is basically the check function that says, okay, return true if it still crashes, false if it didn't, right? It makes testing pretty easy if you do something like that. So reduce it based on new lines, and then you split based on every character in the data using the same logic. And then that's how you get the very reduced data that looks like this. Does that make sense?
Yeah, makes total sense. I was just wondering if you have like the only the structure, let's say you would like only take the rules without the actual terminals within inside this example that you have here, would be actually cool to use as a template for generating like instances, like multiple instances. But if you only look at the, let's say, non-terminals that you're using to generate this, you could also recombine, right? So you could have like maybe two different attacks that you find, and you could merge them together to create like some other attack that combines both, maybe to check out
so
the
that
different.
is, since I'm using GoFuzz, I'll pull that up. So most fuzzers that are use feed that are, let's see, they use a genetic algorithm that does what you're talking about. So you have a corpus of inputs, and you either, and the fitness function, basically, right? So the fitness function means I explored new code paths. I made progress within the binary or target that I'm exploring. And so you take an input from the corpus, and you either do a crossover and you merge it with an existing input, which is what you're talking about, and then you use that for testing, or you mutate a single one. And if the fitness function says that new input caused progress, whatever your feedback mechanism is for that, then you add it back into the corpus. And so it is a long series of random either mutating or crossing over with existing inputs. Now the YAML code is not doing that. Or the Ruby code that we were just talking about is not doing that. And I think usually call it, oh, maybe it's not here. GitHub Lib Fuzzer. I know where to find it in this one. Crossover. All right, custom crossover test, fuzzer mutate. Okay, so this is, oh, I'm in the header file. Anyways, it's that logic that I just explained. Yeah. Oh, and this is it right here. So this is the main mutation function for libfuzzer, which is what is being used on the first example, fuzzing the YAML on GitLab-Runner. So it performs random mutations, and the crossover is one type of mutation. It will take two inputs and merge them together. Let's see, and yeah, that is, I don't think there's anything else left. Aside from this, it did take a fair amount of effort to create the YAML structure, and it's not even finished yet. So this is the YAML data. There is no JSON schema that we have for the GitLab-ci YAML, which would have made this whole process a ton easier. I could have wrote code to just use the schema as the grammar and generate data directly from that. But since we don't have that, I had to go through the GitLab-ci documentation and write the grammar manually. So targeted fuzzing is much more effective, but it takes effort to set up. And that's about the end of this presentation. So anybody have any questions? Want me to go back, talk about anything else?
I'm good.
Cool. Then I will pause the recording and we'll call it a day.